Good day. We are looking at the review sheet or summary sheet for Lewis structures on organic chemistry. I think the Lewis by now should be pretty easy. It reminds you how you deal with simple atoms. You're just simply looking at the valence electrons present. So if you know the group number, then there's no problem knowing how many dots you have to arrange. So from groups 1 to 4, you're putting a dot on each side. Once you're in group 5 and beyond, now you have to pair them off one by one. So at this point, you should know group 4 elements will have 4 single electrons on 4 separate sides. Those are bonding electrons, so it wants to make 4 bonds. Group 5, like nitrogen, is going to have 5 electrons. It'll have a lone pair and 3 bonding electrons. It wants 3 bonds. Group 6, things like oxygen, are going to have 2 lone pairs and 2 bonding electrons. It wants 2 bonds. In group 7, the halogens, things like chlorine, are going to have 7 outer electrons. That means you're going to have 3 lone pairs and 1 bonding electron. They tend to form 1 bond. The molecules and ions, I gave you a sheet of instructions for it that probably didn't make much sense, but then I did 7 examples in detail. And that told you the steps you have to calculate down the left, the actual valence electrons you have present, and on the right you have to calculate the total number of electrons they would want ideally. Then you're going to take the difference, bigger minus smaller, the ideal number of electrons minus the actual. That electron difference tells you how many electrons will be shared. It takes 2 electrons per bond, that's why you have to divide by 2. So now you know how many bonds and how many valence electrons. Those are the 2 things you circled. And then the tricky thing was to assemble the molecule, to draw it in the right way. And so it talks about the tendencies. And that was in a PowerPoint, and it's here on the summary. We didn't talk too much about structural diagrams at that point. Lewis structures do feed the structural diagrams, but that came up more with organic chemistry. So when we think about organic chemistry now, we think about carbon chemistry. We should know that organic compounds always have carbon and hydrogen. They may have other elements. Hydrocarbons will have only carbon and hydrogen. We should remember that carbon wants 4 bonds, oxygen 2, and hydrogen 1 when we're trying to assemble molecules. It talks about the sources and uses for these organic compounds. You have to be able to identify alcohols and alkanes and ethers. It doesn't mean you have to name them. It just means if I gave you a bunch of structures, you have to tell me, hey, that looks like an alcohol, that looks like an ether, that looks like an alkane. If I give you the number of carbons in an alkane, you have to be able to calculate the number of hydrogen atoms. And if I give you the number of hydrogen atoms, you have to be able to calculate the number of carbon atoms. We only do that for alkanes. Alcohols, we remember we identify with an OH. And ethers, the oxygens in between 2 carbons. Isomers, and so these things are actually called structural isomers. It means they have the same molecular formula, but we've arranged the elements or the atoms of the elements differently. So C4H10 has all kinds of isomers, and I've given you some examples of how to do that. It gets a lot easier in Chemistry 11 to tell if you have an isomer, because isomers have to have different names. So in Chemistry 11, I'll teach you how to name these things. Once you know that, it's very easy. In this course, if I'm giving you isomers, I will make it pretty straightforward. So that's it. That's your review. Sadly, it looks like no test. What a shame.